Hello everyone, today we will learn how to find the domain of a function. But before we start, we must understand the meaning of the domain. Domain, that's mean where is my function is defined. So that's mean the values of x exist. For example, you have this function fx equal 2x minus 1. This is a linear function. The domain is what? Is the values from negative infinity till positive infinity, and we can write it in a different way like this: the values from negative infinity till positive infinity. These parentheses represent that we do not include negative infinity and positive infinity, we include everything. Okay, you are going to ask yourself what does mean. Again, replace any value in this interval. Here we have the numbers line, negative infinity till positive infinity. Choose any value and replace it in your function. You will have an answer. For example, I want to replace with 2, so it will be 2 multiplied 2 minus 1. That's mean 4 minus 1, 3. So I found the value. That's mean my function is defined. Let's take another example. Fx equal x squared minus x plus 1. The domain of this function again is what? Negative infinity, positive infinity. That's mean here we include all the values and we do not include the negative infinity and the positive infinity. Try by yourself, replace any number here you want. By the end you will have an answer. That's mean my function is defined. Another example, x to the power of 3 minus 2x plus 1. This is polynomial function. Because the highest power is a 3, we call it what? Polynomial function. Again, the domain is negative infinity, positive infinity. So this is what we call it, the domain for these function. Always it will be the same. Okay. Now let's go to what we call it, the fractional functions or the rational functions. For the rational functions, any function I can write it as a fraction. X minus 1 divided by x plus 7. You are going to ask yourself, before identifying the domain here, you must take care of this point, that always the denominator for any fraction must not equal to 0. Cannot be equal to 0. Understood? So to find the domain, we say x plus 7 not equal to 0. So we shift 7 to the other side. It will be x not equal to minus 7. When we shift the number, that's mean the sign will be changed. Understood? So what is the domain of this function? Here is the numbers line. Here we have minus 7, negative infinity, positive infinity, and we do not include minus 7. Why? Replace minus 7 here. The denominator is gonna be 0, and this is what we don't want to have. Okay, so my domain will start from negative infinity till 7 union 7 till positive infinity, and you can leave it as infinity like this if you want. So all the values, we don't include negative infinity or 7 or positive infinity. This is the definition of the domain for this function. Now let's go for another example. The rational function again, or the fractional function. Example 2, we have fx equal 3x minus 8 divided by x squared minus 9x plus 20. First, when we have a fractional function or rational function, always the denominator must not equal to 0. Okay, so you say x squared plus minus 9x plus 20 must not equal to 0. To solve a quadratic function, this function we call it quadratic function, we have 4 ways: graphing, factorizing, completing square, or quadratic formula. But the easiest one here and fast, what we call it, factorizing. Okay, 2 brackets must not equal to 0. What we want to have, here we have the number 20, the number here. So we need to find two numbers. When I multiply them, they give me 20. So we have 4 and 5, and we have 10 and 2, and we have 20 and 1. All of them, they will give me 20. But I want to have here minus 9. Okay, so the best option is the first option. Okay, how can I have it 20? By minus 5 here and minus 4. Minus 4 multiply minus 5, it will give me 20, and minus 4 plus minus 5, it will give me here the value of minus 9. So I write here x minus 4, x minus 5. Okay, so now how to solve them? X minus 4 must not equal to 0, and x minus 5 must not equal to 0. So now let's solve it. X must not equal to 4. We can shift it to the other side. The negative sign will be positive, and x must not equal to what? To 5. On the numbers line now, you can represent it if you want. If you don't want, all the values bigger than 5, less than 4, and even between 4 and 5, if I replace any value here directly, it will give me a value that will make my function define. Okay, so my domain will be like this, from negative infinity till 4. We do not include 4 or 5, plus 4 to 5, we do not include them, and from 5 till infinity. So this is my domain for this. So let's have another example. We have fx equal, for example, 4x minus 4 divided by x squared plus 9. Now, as we said, the denominator must not equal to 0, so it will be x squared plus 9 must not equal to 0. How we solve it? We shift 9 to the other side. It will be negative 9. So directly take the square root for both sides to solve it, because the square root, it will cancel the square here. So it will be x must not equal to positive. So we found something that here we cannot have a negative value under the root. So now choose any value, and replace it here. You will have always a denominator positive. So that's mean my domain, it will be what? Negative infinity and positive infinity. Now let's go with the radical functions. The radical functions, there's a function, I can write it like this: fx equal the root of x minus 4. So here, any function under the root, okay, square root, cubic root, any root, what we call it, radical function. These kind of functions, we have two cases. When we have the index here, even number like this one, the power is 2, or when we have an odd number. The odd number will be a different case, but always the domain for it will be all real numbers from negative infinity till positive infinity. But here we are going to study the case with the even numbers. So first we have a rule we talked about already, that under the root we must not have a negative number. What that mean? That means all the values must be bigger or equal to 0, okay, under the root. Okay, so let's start solving it. So you'll say x minus 4 bigger or equal to what? To 0. Shift 4 to the other side, so x bigger or equal to what? 4. So that means when I replace 4 here, I will have the root equal to what? Root 0 equals 0. So it's a defined function. Choose, for example, 5. 5 minus 4 would be 1. So the answer is 1. So it's defined. But choose a value less than 4. For example, 3. It will be what? 3 minus 4 equal to root 2 minus 1. So that's mean undefined. So the domain here will be from 4 till positive infinity. But here we are going to change the sign to make it like this. That's mean we are including 4. Okay, so we are including 4 till positive infinity, or you can leave it like this, both of them correct. Okay, Let's have another example. We have this function fx equal the root of x squared plus 3x minus 28. Now, as we said before, what is inside the root must be bigger or equal to 0. So x squared plus 3x minus 28 bigger or equal to 0. So let's solve this function. It's a quadratic function. How we solve the quadratic function, by the way? We said we have many ways. So I am going to choose the factorizing, okay? So we have two numbers, the multiplication between them is 28. So we have what? 4 and 7. 4 multiplied 7 is gonna give me 28. But I need to have the difference between them 3. So I'm going to put it plus 7 and minus 4. So the addition between them is what? Plus 3. And the number here is plus 3. So it will be x minus 4, x plus 7. So it will be x minus 4 bigger or equal to 0. Or x plus 7 bigger or equal to 0. So the solution for this one, x must be bigger or equal what? 4, x bigger or equal to minus 7. Now, how can I write my domain? We must make our line numbers. So here what we have, minus 7. Here what we have, 4. Here we have positive infinity, negative infinity. Now, our first condition, as we said before, I don't want to have a negative number here, okay? So now, let's choose any value bigger than 4, okay? 5, for example, and replace it. 5 minus 4 will give me what? 1. So it's a positive value. 5 plus 7, 12, positive value. So positive value, multiply positive value, it will give me a positive answer, always here. So we can take these values. Now, let's take a value between minus 7 and 4. What is it? Let's think 0. 0 minus 4 here, it will be what? Negative answer. And 0 plus 7, positive answer. So minus multiply positive, it will give me what? Negative answer. So negative values. Take a value less than minus 7. Let's say minus 10, for example. Minus 10 minus 4 here, it will give me what? Negative value. And minus 10 plus 7 here, it will give me what? Again, negative value. So negative value multiply negative value, it will give me a negative answer. Positive answer, I'm sorry. So the answer is here what? Positive answer. So where is the values? Where is my domain? My domain when my values are positive. So the domain would be like what? From negative infinity till what? Till minus 7. Am I going to have minus 7 in my domain? Yes, because when I replace minus 7 in my function, I will have the root equal to 0, so it's okay. So I'm going to close it like this. Union. Am I going to include the 4? Yes. Because when I replace it, it will give me again 0, so it's okay. Plus infinity. And I'm going to close my brackets. Why I didn't include all the values between minus 4, minus 7 and 4? Because it will give me a negative answer under the root and we won't need that solution. Let's have another example where we have the function fx equal the root of x minus 4 divided by x squared minus 9. Here you are going to ask yourself two questions. Here we have radical function, and here what we have, quadratic function. Both together makes fractional function or rational functions. We have two conditions we said, and we talked about them already. First, what is under the root or inside the square root must be bigger or equal to 0. Okay, and for the denominator, here we said we must not be equal to 0. Okay, we cannot be equal to 0. So let's start with the first one. We are going to say x minus 4 bigger or equal to 0. To solve it, shift to the other side, x bigger or equal to what? To 4. Understood? So this is the first one. Let's go to the second one. X squared minus 9 must not equal to 0. X squared must not equal to 9. Here, take the root for both sides. X must not equal to what? Two values, negative value or positive value. So now, let's continue the solution. Where is the numbers line? Here is the numbers line. Here what we have negative 3. Here we have 3. And here what we have 4. So now what we said that all the values less than 4, I'm not gonna take them because they are going to make the value here negative. So are going to exclude everything. So my domain is gonna be all the values from 4 and goes on till infinity. So my domain will be what? 4 till what? Till infinity. Understood? We are going to include the 4 in our domain. Understood? Because if we replaced it, it will be what? 4 minus 4 divided by what? 4 squared minus 9. It will be what? 0 divided by what? By 7. It is 0 and it is defined. Okay? But if we had what we call it 0 in the denominator directly, we call it undefined. We cannot have 0. Okay? Let's move to another example. We have this function fx equal the root of x plus 3 divided by the root square of x squared minus 16. So we have two radical functions. Okay? We said always that what is inside the root must be bigger or equal to 0. At the same for this one, bigger or equal to 0. But in this case, we are not gonna put the equal sign here. Why? Since we are in the denominator, we said must not equal to 0. So we are going to erase it, okay? So it's gonna be x bigger than 0. So I'm not gonna take this part. So let's start with the one in the numerator. We said x plus 3 bigger or equal to 0. So that means x bigger or equal to what? To minus 3. This is the first part. Let's go to the second one. We said x squared minus 16 bigger than 0. I'm going to solve it by factorizing. And we are going to explain factorizing in the future, so don't worry about that. So it will be x minus 4 plus 4. Okay? Now, we said that we have here two values. So now we have the line numbers. So we have here minus 4 and here what we have 4. We are going to study the sign now, okay? Where it's positive or it's negative, okay? So now take any value more than 4 and replace it here, okay? So now it will be what? For example, let's choose 5. So when I'm going to choose 5 minus 4, positive value. 5 plus 4, positive value. Positive multiply positive, it will give me a positive value here. Let's choose any value less than minus 4, minus 5 for example, okay? Minus 10, minus 20. It's up to you, okay? So it will be always here negative value and here again negative value. So negative multiply negative, it will give me positive value. Let's choose any value between minus 4 and 4. 0 for example. 0 minus 4, it will give me negative value. 0 plus 4, positive value. Multiply them together, it will give me what? Negative value. Now, let's go back to the first one. Go back to the first one. We said here what we have minus 3 and we said all the values bigger than minus 3. So all the values here, okay, we are going to take it. Now, so this part we are going to exclude it. Why? Because all the values less than minus 3, we don't need them. Because if you replace them in your function here, you will have a negative value under the root. So we are not going to take it at all, okay? Now, here again, we said the same thing. All the values more than 4. More than 4 is positive value. But look, less than 4, it's a negative values, okay? So now, we are going to exclude this too. Understood? Because it is all less than 4, it will give me a negative value. Do you want to confirm by yourself? Choose any value less than 4. For example, let's say 3, okay, or 0. Replace it in my function here, for example. So it will be what? Root of 0 plus 3 divided by what? Root of 0 square minus 16. So it will be what? Root 3 divided by root minus 16. We found the negative value, so it is undefined. Okay, so my domain, I'm going to write it like this. My domain will be all the values from 4 till positive infinity. Am I going to include number 4? No, we are not going to include number 4, because if I replaced 4 here, it's gonna give me 0, and this is undefined. Okay, so this is our lesson for today. Thank you so much.